San Jacinto Peak is 3,302 meters above sea level here. And we'll look at the elevation data from Google Earth. And there's 2 points I want you to pay attention to. The first one is here at 44 kilometers from the observer, and there's a small bump, if you will. That's 75 meters above sea level. And then the next one that we're going to pay attention to is this one at 99.4 kilometers from the observer at 508 meters above sea level. And then you have the mountain up here. So let's look at this in GeoGebra. And this is to scale, which means that we have a circle with a radius of 6,371 kilometers. So the units here are in kilometers in order to prevent too much zooming. And here we start seeing why we can say that the Earth is actually locally flat, which means it seems flat. Even at 200 kilometers, if you look at this in scale, it's not much of a drop. So the Earth is a big planet. So in this video, JTolan claimed that he was 150 feet above sea level when he took the picture. That translates into 46 meters. So this is what you see here. And this purple dotted line here is basically the straight line. Like if you had a really powerful laser which was perfectly level, this is the ray you would see. It doesn't follow the Earth curve. And the other lines here we'll get to. So we have our observer. And just to note that here is the horizon point. For an observer at this elevation, this is where the horizon will be, around 24 kilometers from the observer. And this will of course vary with observer height. So we meet the first point of interest here at 44 kilometers. And just note that it's 44 kilometers along this line, which is the Earth's surface, not the number line, even though they're quite close. Again, because the size of the Earth, you know, the curvature isn't that big. And we see that this green dotted line here is the line from the top of this point to the observer, which means that anything below this line from now on you won't see. And now we come to the other point of interest, like the other obstruction or peak or bump at 99.4. Again, it's 99.4 kilometers along the surface, not the straight line. Again, they're fairly close. But we see that this other obstruction, even though it's higher by a factor of 5 or 6, it seems, you won't see that because the first obstruction will kind of cover it. And this is, you know, perspective in practice. And here we have our mountain. see that the height is 3.3 kilometers tall. We see that the distance from this green line to the top is 700 meters basically, and that means that you'll see around 21% of the mountain you can see. The rest is hidden because of this first bump. Okay, so what's about the other line here, the other dot here? Of course, before I mention that, I should say that this blue line is obviously the line from the top of the mountain to the observer. Now, things will change if we change the observer height. So let's go up to 75 meters. We now see that these 2 points they coalesce, so to speak. And we'll look at why in a few seconds. But first I just want to turn on this kind of brownish line. And you'll see that if I raise the observer height even more, the difference between these two gets bigger. And what I would say now is that what's visible now, if you have this observer height, is around 800 meters. And let's zoom back to see what's happening here. You'll see that the brownish dotted line is whatever is below this brown line will be blocked by the second obstruction. So we're actually at the place now where first obstruction won't block the second one. So this green line is now below the brown line.